Okay, so today we're going to start on 4.4. Guys, listen to me. 4.4 is supposed to pull everything that you know and kind of pull it together and make it mean something to you. Okay? For some of you, you'll be like, oh, that's really cool. Some of you will be like, what's cool? I don't get it. All right? But if you just keep on working the problems, it'll come to you. It may take 3 weeks, and that's okay, because you just work the problems the same way. And if you do exactly what I tell you to do, okay, then you'll be okay. The most common mistake, the thing that's going to make you miss the problem the most are positive and negative signs, okay? Because up until now, we've pretty much just talked about angles in the first quadrant, and now we're fixing to push them all through the quadrants. So I'm going to show you 2 ways. One's to do it, and the other one is to check. You see what I'm saying? If that's the most common mistake, then it's nice if I have a little check for myself. Okay? All right. So here we go. Now look, after this section, I'm gonna work today on this section, and I'll work. What's today? Wednesday. I'll teach Friday on this section, and then I'll give you a worksheet on Friday and give you time in class to work on it. I think I'll finish on Friday, and then we're going to have a test. It's going to be over 4.1 through 4.4, but I want to give that worksheet back to you before we have the test. So what I'm going to do is we're going to be I'll finish teaching 4.4, and then I'll give you the worksheet, give you some time in class, so if you have some questions and stuff, okay? And then you'll turn the worksheet in. It has like 132 answers on it, okay? It's not that many questions, but like when every question you're doing sine, cosine, tangent, cosecant, cotangent, secant, and cosecant, then that's a lot, okay? So, and I'm grading every one of them, okay? If you got your unit circle thing back, I did that as a completion grade because I didn't want to grade all those boxes. I told you it was important because you're going to use it later on the graph, but I hope you paid attention. I didn't grade it. But this one, I will grade, and I want you to get it back before you take your test. So we'll move on, and then later on we'll take that test, probably a day or so later, okay? All right, so trig functions of any angles. So let's pretend, got a little coordinate plane here. Now y'all listen, everything that we're going to talk about today, we have talked about before, and you know it. We're just going to take on a different aspect of it, all right? Let's say that I plot the point 3, 4. Okay, 3, 4. So this is like, remember we called it T. Do y'all remember that? Yes? Okay, so I'm going to plot it. Right 3, up 4. So here he is. That's the point 3, 4. Now I want to make a triangle out of him. Okay, I'm going to make a triangle out of him. So you're always going to draw from the origin to that point. Okay, now, and then I'm going to, I got to make a triangle, so I got to drop a perpendicular. Who am I going to drop it to? Very good. Stay away from the y-axis. Now listen to me, I'm going to warn you about this, okay? The closer they put that point to the y-axis, the more the y-axis will try and suck you in and make you draw that perpendicular to it. If you do it, it's wrong. Everything will be wrong, okay? So be careful about it. The angle is always going to be the angle that's closest to the origin, all right? Tell me what the length of this side right here is. Yeah, that's my x, all right? You went right 3, so this side's 3. Tell me what the length of this side is.
4.
Yeah, that's my y. You went up 4, okay? So this is my x and this is my y. What's the other letter we've talked about before? X, Y, and R. Yeah, this is my R. Y'all, if this were a circle, this would be the point on the circle. Okay? So this is my R. It's also my hypotenuse, right? So you could do a squared plus b squared equals c squared, or you could use the equation of a circle and do x, whose center is at 0, 0. Do x squared plus y squared equals r squared. They're the same thing, okay? They're the exact same thing. So, x is 3, so 3 squared plus y is 4, 4 squared equals r squared. What's 3 squared?
9.
Plus 4 squared?
16.
So r squared is 25, what's r? 5. Okay, so this is 5. Alright, I'm going to, most of the time, for the sake of time, I'm only gonna find the sine, cosine, and tangent. If I find the sine, cosine, and tangent, can you find cotangent, secant, and cosecant?
Yes.
Okay, so remember that we wrote them in the horseshoe so that the ones across from it were the reciprocal functions and you just flipped them. Alright, so I'm gonna find the sine of theta, the cosine of theta, and the tangent of theta. Okay, this 3, 4, 5 is called a Pythagorean triple. His sides are all integers. Okay, it doesn't have any square roots or anything that can't be simplified, so that's called a Pythagorean triple. You're going to see a lot of them on this worksheet. If you can do it however you want to, you can go, oh heck, heel of ants, and that's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Or you can remember sine, cosine, and tangent in terms of x's, y's, and r's. Okay? Now y'all, that's really easy, and I told you you had to know it. I've already written it. We're gonna write it again in just a second. But who does sine go with? Y. So that's y over r. Who does cosine go with? So that's x over r. Who does what is tangent? Sine over cosine, y over x. When those denominators are the same, they're going to cancel each other out, and so he just becomes y over x. Okay, so whichever way you want to do it, it doesn't make any difference. Tell me what the sine is. 4 over 5. Opposite over hypotenuse, y over r. 4/5. Tell me what the cosine is. Adjacent over hypotenuse, or x over r. The tangent. Sine over cosine, y over x. Okay? Anybody got a question? Okay, so let's talk about that little x, y, r thing, because I've already told you you have to know it, so we're going to do it one more time. I'm going to pick me a point. I'm going to draw me a circle on my coordinate plane. Okay, I'm going to pick any point on this circle. Y'all, right now I'm putting him in the first quadrant, but really we could put him anywhere we wanted to. He could be in the first quadrant, the second quadrant, the third quadrant, or the fourth quadrant. Doesn't make any difference. Okay, so I'm going to put him right here. He's going to be the point x, y. So he has no restrictions. X can be anything you want him to be. Y can be anything that you want him to be. Now, you have to be able to draw a triangle. Some of you won't need the triangle, but some of you, like, you want to see that picture, okay? So remember that you always, now that's my radius. From the center of a circle to any point on the circle is my radius, okay? When you always go back to the x-axis, stay away from that y-axis, all right? And then this side running along the x-axis is going to be this x value. This side that runs parallel to the y-axis is going to be my y value. And now I have my x, y, r. What's the relationship between x, y, and r? Yeah, x squared plus y squared equals r squared. You got to know that, okay? Because y'all listen to me. The worksheet that you're fixing to do is called the XYR worksheet, okay? So that's all it has to do with. Now, somebody tell me something about this r right here. Tell me what kind of number can it be?
Any number that is in position.
Any number that's what?
Bigger than X and Y.
Bigger than 0, right? Because if it's 0, do you have a circle?
No.
No, you just have a point, right? And if it's negative, I don't know what that looks like. That must be like one of those, what is that, a black hole or something out there in space? All right, so we know that R right here is always positive. That's very important for you to understand and know, okay? Very important. It's gonna come back into play. I'm gonna show you why that's so important today, all right? So what I want you to do is I want you to define the trig functions in terms of x, y, and r. Okay? Define the trig functions in terms of x, y, and r. This is my theta. Okay? My theta is always the angle that has a vertex at the origin. So I'm going to go the sine of theta, the cosine of theta, the tangent of theta, the cotangent of theta, the secant of theta, and the cosecant of theta. Okay? Any way that you want to. If you're still hung up and you go, oh heck, a hill of ants. I can do it that way. It's not a big deal. All right? I'll look at my theta. Sine, opposite over hypotenuse. What is that? Y over R. Okay? Look, here's a common mistake, because y'all listen to me. They're going to ask you this stuff on another worksheet that we're going to do. Okay? And they could ask you this stuff on a test. Here's a very common mistake. Some kids will say sine is Y. Sine is only Y when you're on the what? What does R have to be for sine to be Y? 1. So that's only on the unit circle. If you're not on the unit circle, in other words, if you change this radius to anything outside of 1, then sine's not Y, it's Y over R. So be careful with that. That happened one year, and I had to change the way I said something and go back and make a big deal out of that, because we say sine is Y and cosine is X, sine is Y and cosine is X. We say that a whole bunch, okay? Cosine, adjacent over hypotenuse, X over R. Tangent, sine over cosine, Y over X. Opposite over adjacent. Okay, now the reason I made y'all write these in a horseshoe like this is because then your reciprocal functions will right across from each other. So this becomes X over Y. Secant is the reciprocal of cosine. He becomes R over X. Cosecant is the reciprocal of sine. He becomes R over Y. And I need you to know this. Okay? I need you to know that. You ready? So far it doesn't seem so bad, right? Does it seem different than anything we've been doing?
No.
No? Seems good. All right. So we're going to say let -3, 4 be a point. We are going to find R and the sine, cosine, and tangent of theta. All right. So first thing I'm going to do. Let's don't do that. Let's see if we can do it without it. Okay. Do I need to draw a picture? No. Do we know how to find sine, cosine, and tangent in terms of x's, y's, and r's? Okay. So I don't really need a picture. Does everybody agree? Tell me what x is. Okay. So x is equal to -3. Tell me what y is. 4. We don't know what R is. Can we find it?
Yes.
It would. X squared plus y squared equals 5. R squared. All right, Kevin's telling me the answer over here. So Kevin just looked at it and said, oh, that's that Pythagorean triple. Okay, so I'm going to make this warning right now. When you see numbers like 3, 4, 5, you're going to start seeing them a lot. and you're gonna go, oh, I know it. Okay, so here's what they're gonna do to mess you up. I want you to be very careful going, I know it. They're gonna give you, this side is 3, and they're gonna give you the hypotenuse is 4. Is that a 3, 4, 5?
No.
That is not. So be careful just looking at a 3 and a 4 and assuming that the other side is a 5. Okay? That's only if the 3 and the 4 are your legs, then your hypotenuse does become a 5. Does everybody understand? Okay, so they're gonna be tricky. They're gonna see, do you really know what you're talking about? So make sure that you know this -3 right here. If you use your calculator, which I hope you don't, but whatever. If you use it to square it, you have to put it in parentheses. Plus 4 squared equals r squared. -3 squared is 9 and 16. There's my 25 again. And when I square root both sides, I get my old 5. Okay? So they asked me to find the sine of theta, the cosine of theta, and the tangent of theta. Since I didn't draw a picture, I'm not thinking of, oh heck, a hill of ants, okay? I'm thinking that sine goes with y, so that's y over r. Cosine goes with x, that's x over r. Tangent is sine over cosine, y over x. Is everybody okay? All right, so sine, y over r, tell me what it is. 4/5, perfect. Cosine, x over r,
-3/5.
-3/5. Okay, so look at this. Can I put that negative sign at the top, in the middle, or at the bottom?
Either.
And it be the same answer?
Yes.
Yes, does everybody understand that? I can put it wherever I want to and it means the same thing. All right, so what's gonna happen is they're gonna give you something like this, all right? If it's a sine or a cosine, I know where the negative goes. Do you agree? Why?
Because it's
Oh, there you go. Because your radius is positive. Oh, look at there. She hadn't even been in school since March. Come on, people. Step it up.
I don't know what.
Step it up. All right? So, yes, because your radius is always positive, then that negative has to belong to that y or that x. Okay? Now, what if it's a tangent and I put the negative in the middle? Do you know who it belongs to? No, you won't. Okay, so I'm gonna have to figure out something. I'm gonna have to show you what that is. So tangent is y over x, so that is a -4/3. Or you could write it as -4/3, or you could write it as 4/-3. It's all the same thing, people. Okay? Now I'm gonna draw a picture of it, because when I draw a picture, we're gonna get into something else that we're gonna talk about before we leave today. Okay? I'm gonna graph my point. It's kind of like the same point that we graphed up here, except instead of it being in the first quadrant, this guy is in the second quadrant. So he goes left 3 and up 4. He is this point right here, -3, 4. Okay? All right, now watch something's fixing to happen. First of all, what's the first thing? Let's draw the hypotenuse. What's the hypotenuse going to be? Yeah, from the origin. It's just the radius of my circle. Do you agree? Okay, and then where do I drop my perpendicular? To the x. Always go to the x. Remember how when we did that unit circle, we came off that x-axis and we subtracted the angle and then we added it. Subtracting it took us in the second quadrant. Adding it took us in the third quadrant. Then we went to the 360 and we backed off that many degrees. We subtracted it. So we're going to drop it down here. It's going to be perpendicular. Let's see, we found r to be 5, so this is 5. Do you agree? What's the length of this side right here?
3.
Yeah, and I'm going to put -3, okay? Because the negative is important. If I'm talking about those functions, that negative is that sign that I'm telling you, positive and negative sign, that's going to be a problem. And this side right here is what? 4? Okay, does anybody know where theta is?
It's the one across from the line.
Y'all, this is theta.
What?
Yeah.
Oh.
This is theta. Your theta is an angle in standard position where that radius is the terminal side, okay? So remember what standard position is. Do y'all remember what standard position is? It's where your vertex is the origin and your initial or beginning side of the angle is the positive x-axis. And then you rotate. You can either rotate up for positives or you can rotate down for negatives.
That's the first thing we learned.
That is the very first day we were in this class, okay? Very first day we were in this class. So this is my theta, but this is actually the angle that I used when I found all these trig functions. Do you agree? I'm going to call this angle right here theta prime. Do you remember using that little prime mark? It looks like this. Remember using that in geometry?
Yeah.
Okay, y'all listen to me. There's a huge relationship between theta prime and theta.
In geometry.
Yeah, you used, like, you would talk about triangle ABC, and then you would, what did y'all call it? You would move it, shift it, slide it, flip it, dilate it, do all those kind of things, and then you would call it triangle A prime, B prime, C prime. Okay? Okay, well, don't worry about it. That's what that means, a prime, okay? It's not feet or anything like that. It just means a prime. So, that's no big deal. All right, so here we go. So here's what I just did. I just introduced you to another quadrant. I took you out of the first quadrant and I put you in the second. We're gonna go anywhere we wanna go, okay? So, here we go. Since we can be in any quadrant, now, we must be aware of the changes in signs, S-I-G-N-S, okay? Y'all listen to me. If you get the numbers right and you miss the sign, you're totally wrong. There is no partial credit, okay? This is huge right here, big, okay? So let's talk about it. All right, let's talk about it. In the first quadrant, tell me about the X's and the Y's. They're both positive. So the point looks something like positive, positive. Do you agree with that? So do you agree that when I'm talking about the trig functions that they would all be positive? So that's why we haven't talked about positive and negatives yet, because we've only talked about the first quadrant, okay? What about the second quadrant? Yeah, the second quadrant's gonna be negative, positive, all right? So that means that anybody that has a what in it? An X. Anybody that has an X in it is going to be negative. Do you agree with me?
Yeah.
Okay, so obviously, who's the first one that you come to? Cosine. Cosine is gonna be negative. And if cosine is negative, who else is negative? Yeah, his reciprocal function, because he keeps the sign. All right, that's reciprocals don't change signs. So, secant. Anybody else have an X in them? Tangent. Tangent's y over x, okay? So tangent function is going to be negative. And cotangent function, his reciprocal. All right, is everybody okay? Let's look at this third quadrant down here. This third quadrant, what's his point going to look like?
Negative.
Negative, negative. So anybody that has an X or a Y is going to be negative. What if they have an X and a Y? They're going to be positive because it'll be a negative over a negative. Okay? So I'm talking about sine, because that's Y over R, which means you're talking about cosecant. Are you with me? I'm talking about what else?
Cosecant. Or not cosecant, cosine.
Cosine. And that makes me talk about secant, his reciprocal. But I'm not talking about tangent because that's y over x. So negative over negative will be positive. All right, everybody with me so far? Okay, what about this fourth quadrant? What are those points gonna look like? Okay, they're gonna be positive, negative, alright? So this time, anything that deals with a y is gonna be negative, alright? So tell me who's the first guy? Sine, and his reciprocal? Cosecant, okay? What about cosine? No, cosine's not, he's an x over r. What about tangent? Yeah, because he's y over x, so tangent and cotangent. Alright, so you need to know all this stuff. Now, would you like for me to show you a nice cool way to know it?
Sure.
Really easy? You want the difficult way? If you want the difficult way, this is it right here. I don't like this because really, in this one right here, what are you talking about? Negatives. What? I don't like to talk about negative stuff, okay? So, we're going to only talk, I'm gonna say talking about the positives. Goodness knows, in this world, we need some positives. Alright, so we're only talking about the positives, alright? So this is the way you know it. I'm just gonna write the letters first and then I'll come in and write the words behind it. And then I'll tell you what it means. So I'm fixing to write 3 things around here, alright? So, all students take calculus. Okay, so here's what it stands for. All students take calculus. When I learned this when I was in school, I was back in Arkansas, and my teacher, Mr. Houston, he went to Arkansas State Teachers College. So how did he teach it to us? Arkansas State Teachers College. All right? They don't even have that college anymore. Well, they do. It's called UCA now. But so that's the way we learned it. All right? But now they do it like this. All students take calculus. So what does that mean? That means that in the first quadrant, all are what? Positive. Okay? In the second quadrant, who's positive? Who starts with an S? Sine. Sine and what? Cosecant? Who's positive in the third quadrant? Who's T symbol? Tangent. Alright, tangent and cotangent. Who's positive in the fourth quadrant? Cosine, sine, cosine, tangent. So those are only the 3, okay? Cosine and his reciprocal, which is secant. Okay? So this is a whole lot easier. You will see me a lot of times if I'm trying to help you with something, then I'm going to do this on your paper. All students take calculus. And I'm going to say, okay, tell me where this thing could be. Alright? So we're going to write something down. I'm fixing to show you why it's important. Okay? But start it. You must always, now listen to me, I'm working so hard to try and keep you from making the mistake. The mistake is going to be with the positive and negative signs, okay? I mean, we've just talked about it. It's pretty involved. You must always think, what quadrant? Does it make a difference what quadrant you're in? Yes, y'all, that's going to change your signs, okay? So, here's the questions. The 2 questions. This is going to be the first question. Every time I have a problem, I'm going to ask myself this question. And that's going to take care of my signs. Okay? I'm going to say, where am I? And what's my sign? Okay? Where am I and what's my sign? This is what I'm going to do to help you get that all straight. And then I'll show you another way to check it. All right, so everybody okay?
Yeah.
All right, so here we go. Example 2. Okay, example 2. The first thing I'm going to tell you is that the tangent of theta is -5 fourths. The tangent of theta is negative 5/4. If I tell you that the tangent of theta is negative 5/4, do you know where that angle is?
No.
Yes.
I don't, I can't say.
Wait,
Yeah, I know.
When the negative is on.
Oh, so Kevin made a point. Kevin said, whoa, wait a minute, we do know. And then he said, no, wait a minute. I don't know which one of those is negative. Does that make a difference?
Yeah.
Tell me what two places I could be.
Two and three.
Yeah. Y'all look, here's what I'm doing. All students take calculus. All are positive here, so obviously I'm not there. Do you understand? Tangent's positive here, so obviously I'm not here. I am either in the second quadrant or the third quadrant. Okay? In the second quadrant is where my x's would be negative. In the third quadrant, my y would be negative. Fourth quadrant, sorry. Did I say third quadrant like 3 times? Sorry. Fourth quadrant. I'm in the second or the fourth. Y'all look at where I'm pointing, don't listen to me. So second or fourth. So do you agree that right now you don't know where I am? I'm at second or fourth, okay? So I'm gonna have to tell you something else. And I'm gonna tell you the cosine of theta, don't say it out loud, is greater than 0. Okay? The cosine of theta is greater than 0. Now notice what I did. I didn't just blatantly tell you where I was. I didn't just blatantly tell you that the cosine is what kind of number? A positive number, okay? I did it mathematically, okay? Kind of sneaky. Does everybody know what quadrant we're in?
Yes.
Where?
Fourth.
Fourth quadrant, okay? That's the only place that in the second quadrant, only sine and cosecant are positive. Cosine is negative. So cosine is positive here, all right? They're gonna ask me to find the sine of theta and the secant of theta, okay? That's what they want me to find. All right, so let's see if we can do these little definitions. First of all, what's the definition of the sine of theta?
Y over R.
Y over R, okay? Now look, my brain does not do secant, okay? My brain does cosine and then does what to it? Flips it, okay? So the cosine of theta is what? X over R, which means that secant must be what? R over X. Okay, so I know I'm in quadrant 4. I'm not going to remember anything. I'm just going to write stuff down, people. Okay, in quadrant 4, which one of this is tangent is y over x. If I'm in quadrant 4, tell me what the point is.
4.
Yes, 4 and negative 5. In quadrant 4, your x's are positive and your y's are negative. So this negative goes with that 5. They're not going to tell you that, okay? And sometimes they'll even put it down here on the bottom where you think it goes with the 4, and it doesn't really, because I could put the negative at the top, in the middle, or the bottom, and it's all just a negative 5/4. You don't really know where it goes, okay? So it is 4, negative 5. So x is equal to 4, y is equal to negative 5. Is R 3? No, people, it is not. This is what I was talking about. This is what I was warning you about. They're going to try and trick you, okay? You see the 4 and the 5 and you go, oh, that's Pythagorean triple. 3, 4, 5? No, that's only when the radius or the hypotenuse is the biggest number, all right? So it can't be a 3. So you're going to have to go over here and you're going to have to say 4 squared plus negative 5 squared equals r squared. What's 4 squared? 16 plus, what's negative 5 squared?
25.
Equals r squared. What's 16 and 25? So what is r? Very good. Does the square root of 41 simplify?
No.
Okay, so remember this. Remember what the rules are in trig. Can I have a radical on the bottom of a fraction?
Yes.
Yes, that is perfectly legal in trig. It will not be legal next semester when we do college algebra, but right now it's legal. But your radical must be simplified. So if you leave the square root of 8 somewhere, that's another warning, okay? If you leave the square root of 8 somewhere on your paper in your answer, I'm going to mark it wrong. If you left a fraction 6/4, I'm gonna mark it wrong, okay? All fractions must be reduced and all radicals must be simplified. So my R is the square root of 41. What's someone else gonna do? Someone else is gonna say, oh, that's, and they're gonna round it off. If you round it off, you're giving me an approximation. I'm not asking for that. Eventually, they're gonna start using the word exact. What is the exact answer? And that just means don't use your calculator, okay? All right, so here we go. We've got to find the sine of theta. It's y over r. So -5 over the square root of 41. Are y'all with me? If you rationalize this, what would it be?
-5 square root of 41.
Yeah, -5 square root of 41 over 41. You're just gonna multiply the bottom and the top by the square root of 41. Okay, on the bottom, the square root of 41 times the square root of 41 is 41, and on the top you get -5. All right, so I like it when you write it both ways, because then you get used to seeing it both ways. What happens is that if you write it this way, and I ask for the cosecant, and you flip this guy right here, I would mark it wrong. Because then he'll simplify. Sometimes I will give it to you like this, and you're gonna have to go, oh, wait a minute. That's really -5 over the square root of 41. So the more you see that, the more your brain equates those two, and you won't get caught. All right? The other one is the secant of theta. The secant is r over x. So r is the square root of 41 over x is 4. So these are my two answers that they asked for. Anybody got a question? No? No, we're not even halfway finished with this yet. Okay, so here we go. Example 3. Okay, remember the difference between an Algebra 2 book? An Algebra 2 book is not a college book. A PreCal book is a college book. One section, does it have 1 or 2 skills in it? No, it has like 12 or 15 skills in it. It takes a long time. Like y'all, we've been in school for 4 weeks, and we're on section 4. We just started section 4, all right? We're gonna do chapters 4, 5, and 6 this semester. Okay, so here we go. Evaluate the 6 trig functions at 0, pi over 2, pi, and 3 pi over 2, using the unit circle. Okay, using the unit circle. All right, so let's, first of all, what about all these angles? Does anybody remember what they're called?
Radians.
Stop it, Kevin. I'm gonna throw that rock at you.
Radians.
All right, so what?
Radians.
No, they are in radians, but does anybody remember what these are called?
The ones that aren't on the quadrants.
Oh, okay.
I just feel
So,
that.
yeah. So, they're not in a quadrant. Do you agree? Okay, they are on an axis. But guess what they're called? Quadrant angles. Quadrant angles, okay? These are called quadrant angles. Y'all listen to me. Anytime I see a quadrant angle, this is what my brain does, okay? Because you already know I don't like to recall stuff from memory, because my memory's like, I guess I'm reaching that point. I'm just so old that my memory's going. All right. So when you do a quadrant angle, I'm looking at these 4 points. Do you agree with me? Okay. So tell me what this point is right here.
0,
What? Please tell me you did not write that on that test. Okay? It is not 0, 1. It is 1, 0. Tell me what this point is right here.
0, 1.
0, 1. Tell me what this point right here is. And this point? All right. So these are the ones that I'm using. Okay? And I'm going to find. I'm going to do 0 first. So I'm going to go the sine of 0, the cosine of 0, the tangent of 0, the cotangent of 0, the secant of 0 and the cosecant of 0. This is what they asked for, the 6 trig functions at every angle, okay? So, sine, y'all look, this is what, now first of all, if I'm on the unit circle, sine is y, cosine is x, tangent is y over x. That's it, people, okay? Here's the point, you don't even have to look at the unit circle, okay? Tell me what the sine is. 0. Sine is y, cosine is x, tangent's y over x. That's what it looks like. It's really over r,
What?
but r is 1 on the unit circle. I mean, that's where they got the name, the unit circle. It is 1 unit, okay? And this is y over x, all right? So, sine is y, 0, cosine is x, 1, tangent, sine over cosine, y over x. What's 0 over 1?
0.
If you leave it as 0 over 1, I'm going to mark it wrong. Does everybody understand that? That just tells me you don't know what it is. What's the reciprocal of 0 over 1? 1 over 0, and that is what? Undefined. If you leave it as 1 over 0, I'm going to mark it wrong. That just says you don't know that it's undefined. Okay? Secant, what's the reciprocal of 1?
1.
What's the reciprocal of 0?
Undefined.
Very good. Undefined. Alright, now we're going to do the next one. I'm going to do pi over 2. So I'm going to go the sine of pi over 2, the cosine of pi over 2, the tangent of pi over 2, the cotangent of pi over 2, the secant of pi over 2, the cosecant of pi over 2.
You're too fast.
I'm doing the same thing, guys. Now I'm at pi over 2. Here it is up here. The point is 0, 1. What is the y?
1.
Cosine is x. What's the x value?
0.
0. Tangent is y over x. What is 1 over 0? Undefined. What is the reciprocal of undefined?
0.
Very good. What is the reciprocal of 0? What? Stop saying that. Undefined. All right. What's the reciprocal of 1?
1.
Good job. We got one more.
I
Okay.
got 2 more.
No, y'all. Why are we not doing 2 pi? Oh, we got 2 more.
Yeah, we have pi and 3 pi.
Well, I only did one more on the other class, and I kept thinking, why did I only have 3? And then I was like, oh yeah, 2 pi is the same as 0. That's what my brain said, but my brain is tired. So here we go. Let's do pi. So sine of pi, cosine of pi, tangent of pi, cotangent of pi, secant of pi, and cosecant of pi. See, I was getting up last night trying to make sure my watch was syncing with my phone, and it never happened anyway, so what difference did it make? All right, so I'm over here, okay? Sine is y. What is it?
0.
Cosine is x.
-1.
What's y over x? 0 over -1.
0.
What's the reciprocal of 0?
Undefined.
If I have 1 undefined, what?
2.
You're going to have another one, people. What's the reciprocal of -1?
-1.
-1. Y'all, reciprocals keep their signs, okay? Reciprocals keep their signs. The part of the definition of part of the magic of a reciprocal is if you multiply 2 reciprocals, they equal 1. Okay? So it has to keep its sign. It has to be +1 when you multiply it. Over here, what's the reciprocal of 0? Undefined. Alright? Now we'll do the last one. The sine of 3 pi over 2, the cosine of 3 pi over 2, the tangent of 3 pi over 2, the cotangent 3 pi over 2, the secant 3 pi over 2, and the cosecant. Okay? So, now I'm down here. Sine is y. -1. Cosine is x. Tangent's y over x. Sine over cosine. What's -1 over 0?
Undefined.
What's the reciprocal of undefined?
0.
What's the reciprocal of 0?
Undefined.
And what's the reciprocal of -1?
-1.
Perfect. Amazing. Y'all are good. Alright, anybody got a question so far? We're just gonna write down one more thing. We're not really gonna talk oh, no, we are gonna talk about it.
I'm just gonna write one more thing down.
No, we're gonna write, we got a couple more things to do. Alright, so this next little thing is just kind of a review, okay? So I'm gonna review you. Okay, calculator. Alright, so, just a quick review. Let's say that, I'm gonna find the sine of some angle, or the cosine of some angle, or the tangent of some angle. Can you do that in your calculator?
Yeah.
Yes? Tell me what I would be looking for, an angle or a side?
An angle.
Yeah, why, Kevin?
Because you're gonna angle.
Yeah, I already got an angle, people. I don't need one.
Oh.
All right? If I give you an angle, I don't need an angle. You're looking for a side. It's just a number, okay? It's just a number.
Well, I'm mistaken, it's not 42.1.
No, so it must be in radians. Did y'all hear that? That's something really important to know. I've done that to you several times, okay? This right here, is this degrees? How do you know?
Because
Yeah, it doesn't have a little degree sign, okay? It's not degrees, it doesn't have a degree sign. So, what happens when I use, what if I did these? What if I did the cosecant of 32 degrees, or the secant of 6 pi over 7, or the tangent of 25 degrees?
You do the same
Okay.
thing that you do.
Then, am I still looking for a side?
yes.
Yeah.
Okay, so here's my question. Where does the x to the minus 1 button go?
On the very.
On the left side of the calculator.
Thank you very much, Layden. So, Layden says on the outside. Remember the way that I told y'all to do, okay? What is this button? You tell me what this button's called.
Reciprocal button.
This is the reciprocal button. Okay? When do I use the reciprocal button?
When you
When
use
you
it,
wanna find,
That's right. So, y'all, there is no cosecant button on my calculator, so you're gonna have to use the sine, all right? If I use the sine function, the reciprocal function, I have to use the reciprocal button. So what's actually gonna happen on this guy is you are going to find the sine of 32.
-1.
parentheses.
Oh, sorry, don't do that first parentheses, I don't know what happened. I need another cup of coffee.
Wait, you're not-
It goes right here. The calculator automatically opens it. You have to close it, okay? And put it on the outside. It's on the outside because you're looking for a side. Where are the sides of a triangle? On the outside or the inside? Okay, they're on the outside, so he goes on the outside. That's an easy way to remember. Now, what if I use one of these? An inverse sine, or cosine to the minus 1, or arc tangent. Are all of those the same thing?
Yes.
Okay, so all of these, what are you looking for? An angle, okay? All of these, I'm given an angle and I'm looking for a side. All of these, I'm looking for an angle, okay? I wanna know, what is the angle? Where does my x to the minus 1 go if I'm doing these over here? Cosecant, inverse cosecant, arc, secant. All of these things mean the same thing. It says, what angle, like this one right here, says, what angle has a sine of 0.5? What angle has a sine of 0.5? This would be what angle has a cosine of, and it would be whatever number I put right there, okay? 0.429. What angle has a tangent of 42.3? All right, these are the reciprocal, these are their reciprocal functions, inverse cotangent, all right? Obviously, these are not on my calculator. You're gonna have to use the reciprocal function, so you have to use the reciprocal button. And where does it go? Yeah, on the inside, okay? So this is the way I taught you, Okay, I said, people, if you're looking for an angle, it goes on the inside. Because if you think about a triangle, angles are on the inside, sides are on the outside. If you're looking for a side, it goes on the outside. If you're looking for an angle, it goes on the inside. Okay? All right. So, do we need to practice a couple of those?
I think we're doing okay.
Yeah? You want to practice? Okay, so let's practice. So, evaluate with a calculator. Okay? Evaluate with the calculator. This is example 4A. All right? So, I'm going to give you an easy one first. Okay? Yep, you're just finding it. How many decimal places do you round it off to?
100.
Oh, 4.
4. Okay? In trigonometry, it's proper to round them off to 4 decimal places. Okay? Now, if I'm looking for an angle, they'll either tell you or I say do it too. Okay? Don't do 4. That's crazy. All right. So I want you to do this one, and I want you to do this one. And I want you to do this one. Yeah. Y'all don't have a calculator? Is that what y'all are telling me?
Oh, yeah, I just, no clue.
Okay. So let's what's the first thing I need to do?
Mode and degrees.
Yeah, make sure you're in degrees. Gotta do your mode and make sure you're in degrees. Mine is in degrees, so I'm good with that. So now I'm just gonna go sine of 25, right? Do I have to close the parentheses?
No.
No, he doesn't care. All right, so my answer is 0.4226. Does everybody agree? Okay, now this guy right here, you're gonna have to rewrite him, all right? There is not a secant button on your calculator. So what button do I have to use? Cosine. That's his reciprocal. If I use the cosine button, the reciprocal function, then I'm going to have to use that reciprocal button. Am I looking for an angle or a side? A side. I already have the angle, people. So where does the x to the minus 1 go? On the outside. So my calculator is going to do this. As soon as I press the cosine button, he opens up the parentheses. I put in a negative 132. Do I have to close the parentheses?
Yes.
Y'all, you can't put it on the outside if you don't close the parentheses. Okay, so close it and then raise it to that minus 1. All right? Anytime you use a reciprocal function, you have to use the reciprocal button. They offset each other. Okay, so I'm going to say cosine. I'm still in degrees, so I'm good. And I showed y'all how to use the degree symbol if you want to always leave it in radians. Someone asked me a question the other day, and I don't know the answer to that question, so all you little people that are good with calculators and computers and mess like that, y'all can figure that one out for me maybe. I'll tell you in just a second. Negative 132, close it, and then my x to the minus 1 button. What it's doing is it's taking the cosine of this number, and then it's taking that number's reciprocal. That's what it does when you put it on the outside. Okay, it's the same thing as saying 1 over the cosine of negative 132. My answer is negative 1.4945. Negative 1.4945. Is everybody okay? Okay, so here's this next one right here. So I'm going to be in radians, so I'm going to change the mode. All right, obviously I don't have a cotangent button, so what do I have to use? Tangent. I'm still following those same rules, guys, okay? I'm looking for a side, so the x to the minus 1 has to go on the outside. And so I'll say 7 pi over 12, and then put it on the outside, okay? So I'm gonna say the tangent of 7 pi divided by 12, close it, x to the minus 1. Do I have to use the fraction button here? No? Okay. Here he is. Negative 0.2679. Okay? Negative 0.2679. All right. And then we did some the other way, right?
Yep.
And I said when we do them the other way that I want your answer to be in degrees. Okay? And if I don't tell you, then I just want you to round off to 2 decimal places. Okay? If I don't tell you, I just want you to round off to 2 decimal places. So this is one of the ways that it could look. Bless you. Okay, so inverse cosine of negative. Notice that I only use parentheses when I'm writing a negative number, so it doesn't look like a subtraction sign. Okay, I don't use parentheses up here. You don't have to. It is proper to use it when there's that negative sign there. Okay, so do I have to do anything fancy to my calculator? Just need to make sure I'm what? In degrees. Okay, and this is what one of the kids said. Miss Davis said, I always leave mine in radians, and then up here, he leaves his in radians, and then he puts that degree sign on that 25. That makes it take it as 25 degrees. It will give him the right answer, but then he was like, what happens down here? And I'm like, you're in radians. It's gonna give it to you in radians. Well, and I was like, I don't know. I don't do that. So I'm gonna go over here to degrees. I assume that you could change it to degrees by multiplying by 180 over pi?
Yes.
Okay, so I'm gonna go inverse cosine, that's second in cosine of negative 0.4893. You don't have to close the parentheses, you can if you wanted to. And my answer is 119.29 degrees. 119.29 degrees. Okay, so what happens when you got one of those tricky ones, like this guy? The cosecant, inverse cosecant of 4.217.
You just do sine.
Can I do regular sign?
No, you gotta do the inverse.
Okay, I gotta do the inverse sign, because that's, you only use the inverse function when you're looking for an angle. So obviously I'm looking for an angle, people. Okay, this inverse says, this is the way this is read. Which angle has a cosecant of 4.217? Alright, so inverse sine of, he's gonna open up the calculator's gonna open that up. 4.217.
Close the parentheses and then put a negative.
Okay, do I put that, when I do the reciprocal button, do I do it inside the parentheses or outside the parentheses? Inside the parentheses. You're looking for an angle. Where are angles located, guys? Inside, okay? I mean, think about a picture of a triangle. So, I'm gonna do this. I'm gonna go second in sine of 4.217. I'm gonna do my reciprocal button. Okay, you could close it if you want to. You don't have to. He's not gonna care. And there's my angle, 13.72, right? Alright, so let's try one more. I want to do one like this. Arc secant of 2/3. I don't know why I keep doing that. I'm a crazy person. Oh, I turned my parentheses the wrong way. That's supposed to go with that little F. Alright, arc secant of 2/3. Okay, so now tell me what I have to do.
Second and click sine.
Second and who?
Cosine.
Cosine. Alright, so I'm gonna do inverse cosine of 2/3. Do I have to use my fraction button?
Yes.
Y'all listen to me, if you're gonna use the reciprocal button on the inside, you have to use the fraction button. If you don't, it will take the reciprocal of that second number and you'll be all messed up, all right? It'll be bad. So, we're gonna go second and cosine. I'm gonna get my fraction, that's alpha and F1. I got a 2 on the top and a 3 on the bottom. Get out of the fraction and then press your S to the -1. Okay, and then if you want to, you can close the parentheses. Why does it tell me it has an error? It's not possible, okay? It's not possible. I didn't mean to do one that way. Obviously I thought too hard about it. Cause I started to do it the other way, and then I should just not think, I should just go with my gut instinct like I teach y'all. Alright, so, anybody got a question? We did have something else that we were gonna write down, but we didn't get to it. So, I'll just ask you where it is. The other class, we wrote something down, but we didn't. Alright, so, we're still working on 4.4. We'll finish it up maybe next class. And then I'll give you your worksheet.